Welcome students, we've been given this question to find the Laplace inverse of s over s squared positive 1 raised to the power of 2. Of course, I've already explained to you that questions of this nature can also be solved using partial fractions, but the only thing is that it is very cumbersome. So for that, we would have in other words, we would have to resort to a easier technique, what is called as convolution. Now, we have been embarked on this particular topic of solving questions related to Laplace transforms, specifically inverse Laplace transforms, using convolution concept. Now, just to have a recap, now if you have two functions, say f star g of t, and you have two functions and you are convoluting these two functions, then you got this convolution of these two functions to be represented as integral 0 to t, and this is going to be f of t minus u times g of u times du. Now, since convolution is commutative, you can also have the reverse of this, which I've already explained to you. So for this question, I would be using this convolution to obtain the solution. Now, to start off, what we have to do is we will have to split this given Laplace inverse. So I'm going to rewrite this as L inverse of 1 over s squared positive 1 times s over s squared positive 1. Now, s squared positive 1 times s squared positive 1 will give us s squared positive 1 raised to the power of 2. 1 times s will give us s. So it's just writing it as a product. So there isn't any convolution appearing here. But if I rewrite this as L inverse of 1 over s squared positive 1 asterisk L inverse of s over s squared positive 1, now comes the convolution. You have to understand that convolution is not product. We call it as asterisk. That's it. Now, L inverse of 1 over s squared positive 1, or in other words, L inverse of 1 over 1 positive s squared, this is going to be my sine t, and that is convoluted with s over s squared positive 1. You are taking Laplace inverse. This is going to be my cos t. So you have two functions. So you got this as f of t star g of t, which is nothing but f star g of t. So this is what we are looking for. Now we have to use the technique of convolution onto this particular function. So that's exactly what we are going to do now. Now, using this formula, I can rewrite this as integral 0 to t. Now, my f of t is sine t. So, from here, f of t negative u can be rewritten as sine of t negative u. So, this is going to be my sine of t negative u times g of t. My g of t is cos of t. So my g of u is going to be my cos u. So we can write that cos u times du. Now we have obtained this. From here we can use compound angle formula. So what I'm going to do is I'm going to use this formula. So we know that half times, in fact, let me just use this in this fashion. We know that sine of a times cos of b is equal to half times sine of a minus b. This is a very important formula. Positive sine of a positive b. So if you were to expand this, you will get back this. So I can just show you that. Why am I writing this? So this is equal to half of, now sine of a minus b is going to be sine a cos b minus cos a sine b. Positive sine of a plus positive b is going to be sine a cos b positive cos a sine b. Right. Now Sine A cos B, sine A cos B, these two can be added. Negative cos A sine B, positive cos A sine B, these two can be cancelled. So what do you get? You get 2 times sine A cos B, and that is product multiplied with 1 over 2. So 2 gets cancelled, giving you sine A cos B. So that is why this is a very important formula. So what exactly are we doing? We're connecting a product with a sum. Now why is it important? Specifically in integration, whenever you have trigonometric functions or exponential functions, one of the easiest way to solve them is to convert the product form into sum form. So that is simple as that. Now we have got sine of t minus u times cos of u. So let me rewrite that. Now sine of t minus u times cos of u. Now my a is t minus u, this is my a, my b is cos u. So I'm going to rewrite this as half of sine of my a t minus u, and my b is cos u, I mean u, followed by positive sine of my a is t minus u and my b is u. So let me have it like this, my b is u. So this is going to be rewritten as 1 over 2 times sine of t, negative u will give you negative 2u, positive negative u positive u, this can be cancelled, giving you sine of t. So wherever I see sine of t minus u times cos of u, I'm going to replace this. So let's go over here. So if I were to take this as 2, I'm going to say therefore 2 can now be rewritten as integral 0 to t, this is 1 over 2 times sine of t negative 2u positive sine t. Now this has to be multiplied with my du. Now I'm going to rewrite this as, now you got a half there, so I can take the half out and rewrite this as integral 0 to t sine of t negative 2 times u times du positive 1 over 2 times integral 0 to t sine of t times du. So this is what we have got. In fact, okay, that's okay. I place a parenthesis. That's fine. So now we will have to integrate this and then add it up with the integrated value of this. So to integrate this, what I wish to do is I would like to consider integral 0 to t sine of t negative 2u times du. Now use the function here. So I'm going to say let t negative 2u be equal to some p. So I differentiate this left hand side, so I get negative 2 times du is equal to dp. I want only du, so du is equal to dp. I bring the 2 down, in fact I'm bringing negative 2 down, so it's going to be negative 1 over 2. So this is the substitution that I have to use. So hence what happens, this is equal to integral, so I'm just drawing a line here, and probably I will take this as 4 or 3. So hence this thing integral, I'm not going to touch the integral limits, so let it be like that. In fact, I'm not going to place anything there. So this is going to be sine of t negative 2u, that's going to be p, and du is going to be dp divided by, in fact multiplied with 1 over 2 with a negative sign. So place that 1 over 2, place the negative sign. Now if you were to integrate sine p, this is going to be negative cos p. Of course there is a 1 over 2 there, but there is a negative sign there, so place that. Now this can be rewritten as 1 over 2 cos p. But what is p? P is nothing but t negative 2u. Now the limits, what are the limits? The limits are 0 to t. t, because I've now brought them back to the original t minus 2u. So now I can substitute the limits. So if I were to substitute the upper limit, so this is going to be cos of t negative 2 times t negative cos of t negative, u is 0, so you place it there. So this is going to give you 1 over 2 times cos of t negative 2t, that's going to be negative t, and this is going to be negative cos of t. So this is what you have got. Now you can rewrite this is going to be 1 over 2. Now cos is an even function, so cos of negative t is going to be cos t followed by negative cos t. Now clearly you can see cos t negative cos t, they get cancelled, so giving you 0. So the value of the integral is 0. So clearly this vanishes. So I'm not going to do anything now. I need to just first get this quantity out of my way. So now I'm going to say consider integral 0 to t sine of t times du. Now this is a constant, so I can rewrite this as sine of t integral 0 to t times du. Now this is equal to sine of t, integral of du will give me u, the limits are 0 to t, so this is equal to sine of t, substitute the upper limit minus the lower limit. So this one is going to be t times sine of t. So this is what you have got for this. Now I need to take all these values and substitute it in 3. Okay, so hence my 3, I can rewrite 3 as, in place of the first quantity this is 0, but there is a half there, it doesn't matter, right? So half times 0 is going to be 0, but the second quantity is going to be 1 over 2 times, and in place of integral 0 to t sine t du, you will have to substitute t times sine t. So this is going to be t times sine t. So this is the value that you have got, and this is the solution. So this is the right point to stop.